Hi everyone, this is Susila Pangaluri. I'm from PayPal, here working in India, Chennai. I have 10 plus years of experience, and over the past few years, I have been predominantly working on scaling of batches. And so here is a session. I want to share what I have learned from my experience on what are the various scaling options for batch applications. And let's quickly jump in. This is the agenda, the main three items that I will be discussing. The current scaling options. It includes mostly, I will walk you through the legacy options which we traditionally follow and the available modern options and compare the various options that I have walked you through and decide the best one that fits for your usage. The first one, the currently used options. Even before I jump in, what is a batch processing? When we go for a batch processing, let's say service processing is different, wherein you get a request and you process it and send the response to the client. However, a batch application is made to process huge amount of data, that is huge amount of info at one go. That is called as a batch application. And how we can scale a batch application and what are the ways that we are traditionally following so far. Either we go for vertical scaling or horizontal scaling. What is meant by vertical scaling? It is increasing the number of workers, that is the processors, to do the work. But there is a limit to that, wherein even our DB capacity, right, has to agree to the number of workers that would be parallelly processing, but you end up hitting the same DB, where we exhaust our vertical capacity. And there is a limit the hardware can be added, beyond which it can't be added. And the other approach is horizontal scaling. That is, you partition the input data based on something. For example, in this example, it is account number slash %10. That is, everything that ends with 10, you put it in one partition and the others in the other partition and process it. So as the data grows, you have to maintain this. That is, it is not auto-scalable, not elastic, wherein you have to further increase the number of partitions depending on the increasing business that you have. So, and the other one is asymmetric data growth is another loophole in this approach, wherein you have to figure out that because account numbers can be anything and you can't really assure that partition 1 has the same amount of data, number of records as partition 2. So the partition key that you would be choosing, it has to have a symmetric data growth, which is very difficult to figure it out. And it is not resilient. All these systems, I think the developer has to be really careful in building a system wherein if one record, let's say, has thrown some exception, how can you catch that and put that alone in the exception bucket and move on to process the other records? Or he has to be cognizant to figure out, okay, beyond this, the batch should not operate. So developer has to explicitly take care of all these things. And when it comes to multi-threaded programming, in either vertical or horizontal scaling, developer has to put in a lot of effort to code for multi-threaded use cases. So with all this said, right, we have now seen what are the various drawbacks of using just the system alone. But I would say that these are the basis for any systems that are even the modern systems that we have built. But let's not stop here. There are even more advanced options for us, the technologies that can be leveraged for batch processing. Moving on to the next point in our agenda, which are the modern options which are used for scaling. So here you see two pictures, just to name them, right? One is remote partitioning or just partitioning, and the other is chunking. Before I really jump into that, right, there are totally three options that I'm going to talk about. One is partitioning, other is chunking, and the other is using Akka and Scala frameworks. How can we do batch processing? Even before I delve into each and every of the option, these core capabilities which are being shown as colored bars down, right? Chunk oriented, parallel steps, stateless programming, config driven, and callback listeners. So these are the core capabilities upon which these two systems are built upon. Modern options of scaling are built upon. Let's go one by one. Chunk oriented. So if you see any batch that processes, let's say the batch is reading from a server, some shared box which the client puts some files, and your batch has to process it and write into some other file or some other table. So the basic operations that are available, that need to be available, are reading, processing, and writing. So if we can divide these three parts separately while we code into different chunks, the logical classes or entities, then our coding will be simply, it can plug into any of the options that I have shown above. I see in most of the applications, particularly C++ and older technologies, right? Of course, they are very strong in processing, no offense, but we tend to mix up the code, like reading, processing, writing, everything happens in a single object class. So programmer has to be really wary that to divide this logically into three steps, so each module can be reusably plugged and used. The next core capability is parallel steps. Let's say I am reading from a shared box, putting into a temporary box within my local environment, and I want to delete whatever is there in the shared environment and then start my processing and writing from my local environment. So I can here logically separate step one as reading from a remote box to my local box and deleting whatever is there on the remote box. And the step two as reading from my local box, processing it and writing it into another file or box. So this means that like there are steps that can be run in sequence or in parallel. For example, the one that I have said is a serial step. But let's say if I have to gather data from many services or many tables within my processing steps, I think we can code it in such a way that they can run in parallel. So if you are able to logically separate them into steps, each task that this batch has to be done, then the programming becomes even much more easier. And Spring Boot gives us launch context.xml wherein you can configure these steps easily in that configuration file itself. And stateless programming. Like once you have the chunks ready, that is a reader, a processor, and writer, what that is a singleton object that the Spring provides you. And you need not explicitly take care how can a multi-threading operate on my objects, because Spring by itself enforces you to do a stateless programming, which makes it even much more easier to increase the number of threads or decrease the number of threads in your programming. And the next one, core capability, is config driven. I have just mentioned increasing the number of threads or the steps, the sequencing of the steps, and on which step that I have to fail if it returns so and so. All this can be configured. You need not explicitly, like every time when you want to change the number of threads, you need not change some piece of code and test altogether. A configuration file change, then you're done. Callback listeners. So when I say read, process, write, let's say, let's say before reading, I want to do some preliminary, like I want to do some actions or tasks. Let's say at before read, there is annotation available wherein before reading, I would call that at before read for every data. And I want to do some validations that can be done over there. Similarly, after read, I wanted to do something. So there are already few annotations provided by Spring, like which can be used as callbacks, like at before step. Before the step, a step comprises of read, process, and write. And even starting everything, I want to clean up on my remote box. Say that's a at before step. Then you can write that piece of code over there instead of mixing it with your actual code. So you're clearly segregating the tasks among each classes. So all this is available as part of JSR specifications. I think it is JSR 352, which mentions the style of coding, how it has to be based on this core capabilities that I have listed down, the 5 core capabilities. Now, talking about the actual solutions. The first one that I'm showing you here is partitioning. That is, either it could be remote partitioning or local partitioning. So here the master decides on what are the various partitions, the number of partitions that the data has to be broken into. And each set of data is passed to the slave. Slave in turn process a chunk, that is reading, processing and writing happens in the chunk. And the slaves can run on various remote boxes distributed. So which gives us the capability of processing it faster. This is the first approach. And the second approach is remote chunking, wherein unlike the partitioner, the master here just, even without partitioning, it just puts the data, that is a single row of information, into a queue. Here, for example, it's a JMS queue, and these are all the slaves. It's a producer-consumer pattern wherein the slaves are the consumers and they keep listening to the queue. And the reading, processing, and writing happens from the slave. And the response, that is, I am done, is again put back into the JMS queue and goes to the master. So, talking about the relative advantages among these two in terms of restartability, right? Partitioning is usually better in terms of restartability. And if a single thread is operating, then the number of accounts processed and everything is for sure going to be the actual count for a partitioner. But when it comes to remote chunking, right, you can't really guarantee whatever message that a master puts in, this goes to this slave. It may go to any of the subscribers who are ready to consume it, and you can't guarantee like they are done. And input source, let's say like in master, we are not actually passing any of the rows, that is data, over a queue. But over here, the whole message has to be kept in a queue, unlike partitioner. And if you have to really go for a remote chunking process in case yours is a process intensive operation and you can't really decide on a partitioning key, then remote chunking is a better option. And as I said, like not all data can be easily partitioned. There could be asymmetric data also where you can't really go for this option. And then I was talking about the JMS queue, right? Like in place of JMS queue, if we can use queues like Kafka, wherein it guarantees a high throughput, then even remote chunking is a better option. So as I have just now talked about, if it is huge data volume and if structure of the data is clear, then we will go for a partitioning approach. And if it is a process intensive operation on a low amount of data, we go for remote chunking. I hope this is clear, and I'm going for the next option. That is Akka and Scala. This is a new one into the market wherein even this can be leveraged for batch processing. Akka is a programming toolkit wherein it says, I have given this use case for one of my application, wherein it says everything is an actor. That is, and actors communicate with each other asynchronously through a queue. And the core capabilities of this is, it is elastic. Let's say the data coming in, the number of requests coming in are huge. It can automatically span more number of queues, more number of actors, sorry for that. And it is resilient. Let's say in case of failure and responsive, in case of failure, right? If one of the actor takes a long time, then other actors try to grab its work. A kind of that operation takes place. And let's say an actor is not able to, it's a huge task at this actor's point, then it can spawn additional number of actors to do that work. And everything is asynchronous. As I mentioned, it is message driven. An event will be passed. A mailbox kind of concept is there, wherein each actor listens to a mailbox and it processes. The example that you are seeing over here, right? There is a dispatcher, a router which actually routes it to the dispatcher, and dispatcher decides what are all the actors that I have to create, and actors, they are configured which is the next actor that I have to call. The cubes, that is the oval shaped symbols that you see are the different actors. And here also you can divide the actors as few as read actors, process actors, and writer actors. And how to run these actors, either you can go for a random, that is like you mention, like you can work on any of the actor first, or it is a round robin. Okay, only after finishing this actor, go with this actor. I hope this is clear, the proposed solution with Akka and Scala. Scala is a functional programming language that we use using the Akka toolkit. And this is new in the market, wherein it gives additional few more capabilities in case, like, the processing speed has to be really much faster. And now going to a use case. Let's say you have a use case. What are the various things that I have to gaze, that is evaluate upon to decide on which scaling option that I have to choose? There are technical parameters as well as business case, use case parameters. For example, technical parameters. Is that a processor intensive operation? Whether my processor is gathering information from hundreds of services, hits 10 databases, and is there a scope for parallel steps if each service call can be independent? And whereas use case parameters is what is the business growth for this data? How much volume of data is right now? Depending on that, whether the data can be partitioned using some key. What is the nature of input data, whether it is an event-based data or we get it from an offline file, or do I have to read from the DB? And is there any SLA? Let's say, though I say it's an offline batch, is there any downstream application or consumer waiting for the output file that I have to give it to him? So these are all the various parameters based on which I have to choose an option to scale. Now, the next PPT, I want to present a quick view on the four options that I have discussed. The last, of course, the last option is local partitioning, where in remote partitioning it is distributed, wherein the slave runs, each slave runs on different boxes, whereas in local partitioning it runs on the same box. All the load and CPU is occupied on one single box space. Now, coming to, I have compared these four options based on all these criteria. That is time to market. That is, if I want to build it, the first step that I want to build it, how much time it would take. And let's say if I have to enhance it, how long it will take for me to enhance it in and give it to the consumer or put it live in production, what I mean to say. What is the data volume? What is the expected data volume growth? What is the execution time each one takes? So these are all few of the things, and let me go one by one. The blue colored one, if you see the time to market, I have given the highest number of 0 to 6 scale, being 6 being the highest as the number indicates. Time to market is the fastest for Akka. This is also closely related to agility to extension, wherein each module or the actor that I build for Akka can be reused by other modules. So time to market, even to build it and push it to market production, is very fast for Akka. And execution time, as obviously local partitioning, running it on a local box is going to be the highest. And if you see, Akka is having the shortest time to, it is very process intensive. That is, as it is auto scalable, elastic, depending on the load, the number of workers, that is actors, spawn themselves in more number, try to finish the work. It is processor intensive, of course. And the next one, huge volume. For huge volume of data, which is the best one, as remote partitioning is distributed, running on several boxes, and I have the liberty to increase the number of partitions to run it on more number of boxes, remote partitioning is the best one to choose in case your volume is huge. And external dependencies. When I say external dependencies, why I have marked Akka the least, that is more number of external dependencies, as it's new in market, and for large scale companies like PayPal or any other company to adopt when compared to Spring Boot or any other frameworks, is we have to come up with some homegrown customized framework on top of it, which is making our deployment and other associated things to be built around deployment a bit lagging when compared to other ones. In terms of auto scale, as I have just mentioned, Akka has really powerful in auto scaling, and remote chunking also when compared to remote partitioning, auto scaling is faster. The reason is it is put in a message queue wherein the slaves, if one of the slaves finish it, the other consumer, right, the same slave can take from the top from the message queue, it can pull the next available data that has to be processed, unlike remote partitioning wherein you already are given a chunk of data and you process on top of it. But unlike that, remote chunking, whatever is available in the queue, the slave can fetch it from there and keep processing. And agility for extension, in terms of adding new actors, new capabilities, new functionalities, wherein agility for extension includes development time, testing time, regression time. Akka is the fastest in terms you can really segregate the modules tasks into different actors, and which can work in isolation, which makes even testing and regression very fast. So with this, I leave on this screen for a minute so that you could really check on the various colors that I have. I know that it's a bit confusing with all the colors. Maybe I will leave it for a few seconds so that you can go through this slide for more detailed understanding on the comparison. Great, thank you. Thank you for all who are viewing this video, and hope to meet you again. Thank you.
Thanks so much for a great presentation, and we'll have this recording online, as well as if I can get a copy of this PowerPoint, we'll also put this up online as well.
Great, thanks a lot. Thanks a lot.
All right, thanks so much.
Thank you for the opportunity. Look forward to see you again.
It's our pleasure.
Bye-bye.
Thanks so much.